I'm asking you if you have such a problem here. Okay, you have a new fertilizer has been developed to increase the yield on crops, and the makers of the fertilizer want to better understand which of the three formulations or blends of this fertilizer are most effective for wheat, corn, soya beans, and rice. This is all of these one in the crops. They test each of the three plants, one sample of each of the four types of crops. The crop yield for the 12 combinations are shown like this one. Yes, I remember this one. If I call this variable groups, okay, forget about the values. If I'm calling this one groups, so what is the type of the variable groups? This is a variable. Yes, it is categorical variable. Why I'm saying it is categorical variables? Because the category of the groups, I know wheat, corn, soya beans, and rice. Okay, and also what is the other variable? Formulation or blends, if you like. This is also, yes, categorical variable also. Okay. What is the category of this variable? We have three blends. He call it blend X, blend Y, blend Z. What we can do if we have two categorical variables? Do you remember? What test we used for such two categorical variables? Say what's coming in your mind.
Dr. ANOVA?
We didn't get ANOVA before for this one. ANOVA, we compare more than one means, and we have one variable only, right? And this is not one variable in this case, in one ANOVA. Let's go for talk about ANOVA. ANOVA has more than one type, and this is not a name. This is called analysis of variation. We use what? We use ANOVA single factor, or they call it ANOVA one way. They call it one way ANOVA. Okay, we use it to do what? Yes, I just remind you what we have done in the beginning of this lecture. Yes, this is ANOVA single factor. We compare more than two population means, right? And the data in this case, I'm measuring the same thing for the different population, and we're comparing the average of each one of these ones, right? So single factor ANOVA is just to compare only the means for more than two population. Okay, there is another test we used to link two categorical variables.
Doctor,
excellent. Yes. Okay, so yes, we have the chi-square to check what? We have one, here is categorical variable. And here also we have categorical variable. So, and we would like to check if these two variables are associated or not. This is what we have done in the chi-square. Okay. And as we said, all the tests we have done, we have only one null hypothesis and one alternative hypothesis, right? Okay. Today we are going to use a new ANOVA test. It's called two-way ANOVA. Two-way ANOVA. Or they call it two-factor ANOVA. Okay, this two-factor ANOVA has two types. We call one of them without replicant, without. What does it mean without replicant? It means I'm just having only one data for each category, right? Okay. With a replicant, it means we have more than one reading for each category, right? Okay. And what is the point of this one? We heard before about single factor ANOVA. We test the mean one-way ANOVA test or compare, sorry, compare more than two population means. Population. Okay. So what about this one today? This one, as you see, you will get, in this case, for two-way ANOVA, you will have, which is peculiar than the other one. You have two null hypotheses and two alternative hypotheses when you have without replicant. What about if you have with replicant? You will have three null hypotheses and three alternative hypotheses. Amazing this. Okay, let's go and see. And what is the main question for the null hypothesis? From the null hypothesis, we will know the answer of this question. He has two categorical variables, right? And he measured for the category 1 the production of the wheat and the production of the corn and soya beans and rice, and from blend Y the same and blend it. And the question is what? Yes, I would like to check which category in this one, right, if are the most effective for the different type of crops, right? So the question for two-way ANOVA or two-factor ANOVA is just to answer the question between two categorical variables, and would like to check what are the most effective for the groups. Okay, this is to answer this question. You go for two-way ANOVA. If you have this one, what is the difference between this one and this one? This is the same categorical variables, right? The groups and the fertilizer, if you or blends. Okay, but in this case, you have only one reading, right? Okay, but in this case, you have more than one reading. Okay, in this case, I have 5 reading for wheat in blend X, and 5 for blend Y, and 5 reading for blend Z, and for the same for the different or the others groups, right? So we have to distinguish between two ANOVA without replicant, like this one, So the data will be like that. And with replicant, the data will be like that. And I would like to answer the question. Okay. What are the most effective categories, right, on the other categorical variable, right? Let's go for two-way ANOVA tests or two-factor ANOVA tests. As I said, there is one, we call it factor, two-factor ANOVA without replicant, and two-factor ANOVA with replicant. Okay. As I said, in this case, you have two null hypotheses. One related for the first categorical variable, and the other one related to the other one, or the other categorical variable. There is no significant difference in yield between the population means for the groups types. Okay. And the same null hypothesis for the fertilizer or blends. Okay. And it is fair enough if you have two null hypotheses, one for this means for this categorical variable and the other one for the second categorical variables. You will have the alternative, and the alternative, as you said here, there is no significant difference. The alternative will be the opposite. Okay, so you will say there is a significant difference yield between this one. And also here you just deleted the no from this one. You will have the alternative. So it means you have two-tail test. You will do it by the Excel. So please, if you don't mind, I will send you the question and you input this data to your Excel. Okay. And when you have the result, please show it to me. Okay. And how to do this in Excel, right? Let's do it together. I'll open my old Excel and here, let's go and add a sheet. I will delete this one. And this is the last thing we have done. I'm going to add a sheet and call it what? Two factors ANOVA or ANOVA two factors, if you like. And let's see and call this one without replicant. Without replicant. Yes, as you see, the name is very restricted in Excel. So instead of two like this, I use the chat. Okay. Also without. Okay. Okay, two factors. Now I just go and input the data here. This is a question. I got it from the chat. I put it in the Excel. Okay, I will input the table. Okay, wheat, corn. Because this is so difficult to do it by hand. Rice. And here I'm writing blend. I'm lazy in using a computer, so I copy it and change this one by Y. I have it again here and change it by Z. 123, 138, 110, 151. Next row, 145, 165, 140, 167, 156, 176, 185, 17. Sorry. Now, if you'd like to organize this one a little bit, you just make it in the middle, make it bold, and make the border from here. Okay, that's it. Nice. Now, I would like to make the test, so I have to put the cursor in the data. I activate the data analysis already, so I have it. If you don't have it, you just right click and click in customize ribbon. Okay, and come to add ins, and this is the analysis toolbar. Press go, don't press OK now, press go. You will have the hidden packages in Excel. I would like to use the analysis toolbar, so I tick it and press it. Okay. Now, if you put the mouse here, you cannot see the data analysis. Anywhere else, you cannot see, okay, unless you put the cursor in the data. You have data analysis. Do I have ANOVA? Yes, it is organized or sorted by alphabetic, so I will have it. I used this one before, ANOVA single factor. I'm going for ANOVA two factor with replicant or without. This is without, because I have one read or one data for each category. Okay, so I'll go for without replicant. Catch it? Now I have to input the range. How to input the range? I'm just shading all of this one. Do I have a label? Yes. The wheat, corn, soya, rice, blend are labels, so I have to take. Alpha, is it mentioned in the question here? No, it is not mentioned. So let's do it for different type of alpha. So before I forget, I write in the paper, I use it for alpha 5%. Okay. Now I press output range because I would like to have the result just down here, right? Press OK. Yes, I have the result like that. Okay. Now, what I have to catch from this one? Okay, this is a descriptive statistics, give you the sum, the average, and the variance. No need for this one. Yes, I go for ANOVA, and I know this is ANOVA. Yes, I have to write here two ways or two factors without replicant. All the ANOVA, we write only ANOVA, right? Okay. Now, only I'm looking for comparing the stat value, which is here, and with the critical value here, right? Or it is better to go for what? Sorry. It is better to go for the B value, right? Yes, it is better to go for the B value. You have two results for this one. You have for rows and you have for columns, right? We will see why we have two results. Because I have two null hypotheses, right? And I have okay.
Doctor?
Yes.
Doctor, I realized that Excel, sometimes my views are different than yours.
Can you share your screen, please?
Okay, just a minute.
Anyone has any problem with using Excel after typing the table? Yes, very good. Yes.
No, all good.
Okay. Yes. And is it okay? You get the same result, right? Yes. Thank you very much. Now, how to read this result, right?
Doctor.
Yes.
Doctor, for the F critical, you've got, wait, let me show you. I mean, for the F value, you got 2.62, I guess, and I got 2.529. Is that fine?
Not really, no. But look at the degree of freedom. Is the degree of freedom the same as mine?
Yes, doctor.
Okay. So.
Doctor, I even have another question you did before. I got the same problem. Like my results are kind of a little far away from your result, but the degree of freedom is the same.
Yes, okay. This is approximate value, right?
Yes, doctor.
Because sometimes you don't find the exact value in the table, right? So you have the average between two values, right?
Yes.
And some table is not until some table having for F, they have until 30, right? And some table still having until 100. So this is only the difference that you can say, right?
Right, doctor.
Thank you so much. This is back to how to read this one, right? How to read this one. I'll go for the row and I'll go for the column, right? So look at the B value if you would like to use the B value. And as I told you, remember you input alpha as a 5%. So you have to remember it. Otherwise, how you can compare it with your alpha give you this result, right? So if the B alpha is less than 5%, it means you will not accept the null hypothesis. Okay. What does it mean you reject the null hypothesis? It means for this alpha or for the confidence interval, which is 1 minus alpha, 1 minus 5% is 95%. And this is the level of confidence. What is the conclusion? There is a significant difference in the yield produced by the three blends, because I'm talking about what? The rows. So the rows here in my data is the blends, right? What about the other p-value for the columns? The columns here represent what? The groups: wheat, corn, soya, beans, rice, right? So the B value in this case is not less than 5%. It is bigger than 5%. So I'm not going to accept the null hypothesis. Sorry, I'm going to accept the null hypothesis, or I cannot reject it. What I can say for alpha equal to 5% or the level of the confidence 95%, there is no significant difference in the yield for 4 groups studied, right? Catch it? So remember, for two-way ANOVA, without replicant, you have 2 null hypotheses and 2 alternative hypotheses. Once you reject the null hypothesis, you accept the other one, which is the opposite of it, right? Now, let's go for the second one. Here it is. I will give it to you, input the data, and check it. Okay, let's write it. So you add a sheet. Remember here, you have to write, okay, the p-value here is less than alpha. So you have to write something here. What is in the sheet, what is written here, you have to write in the Excel, or you write it in your Word file. I prefer to write it in the Excel, it's better, right? Which is, in my case, is 5%, and you just complete the answer. And also here, it is be this one. And remember, in this case, it is not greater than, it is bigger. It's not less than, it's bigger than, and you complete this one, right? Now this sheet, I copy this one, and instead of without replicant, I'm saying with replicant. Okay.
Doctor, can you just go back just to see the result?
This one, yeah. What you are going to write here is just these two sentences, right? Okay. That's it. Finish?
Yeah, thank you.
Okay, let's go for the data and write it in the Excel for the second question, sorry. Control C. Got the question. Yes, I send it for you, but I will write it in my Excel. So I'll get this one from here. I would like to save a time. Okay. And I have it here. Okay. So what I'm going to do, I have for blend X, I have 5, right? So I will insert more rows. Sorry, I get it down. Okay. So under the X, I will input 4 rows. Okay. Just to save the time, I get the text, and I'm going to okay. Now I have 1, 2, 3, 4, 5, right? So this is a blend X. Okay. Let's write the first 5, 1, 5, 6. The second one, 1, 1, 2, and 100. And the last one, 168. For the corn, 128, 150, 174, and the last, oh, what a mistake in this one. Yeah, the first one is 128. Now I discovered the difference in your, I think this is the wrong one, 128. I wrote it in 138. Okay, 150. Okay, so I'll catch this one and move it up. Okay, 174, 116, and the last one is 100. Is it 100 or 109? 09. Soya, 166, 178, 187, 153, 195, right? 151, okay. 125, 117, 155, and 158. Now I will insert more for rows for blend Y. Sorry. Okay. This is the last one on the 5th row. Now let's write blend Y 135, 135, and 175 for the core, and 140. Okay, 1767 is fine. Let's go for the second row. Second row is 130, 132, 145, and 183. Third row, 176, 120, 159, 4th row, 120, 187, 131, 167. And the last row, 155, 184, 168. I have to add here. No need, because I have a space down here. The first row, 156, 196 or 186. I cannot see properly here. 186, right? 156, 186, and 185, and 175. Okay, the second row, 180, 138, 206, 173. The third row, 147, 188, 188, 154. Fourth row, 146, 176, 165, 191. The fifth and the last, 193, 190, 188, 169. Now I finish. If you would like also to make a border for this one, no problem. Just catch this one. Okay. Now, how I can input the two-way ANOVA with a replicant, because for each category I have more than one data, right? So go for data and already activate this one. Data analysis. Yes, I have ANOVA 2-factor with a replicant. Okay, press OK. You just shade all of your table. It is row per sample. Yes, it is row per sample. How many rows per sample? 5. Okay, 1, 2, 3, 4, 5. Okay, and he mentioned in the question. Okay, If you are going to use, if it is not mentioned in the question alpha, you can do it for different alphas using Excel. Even no need for 5%. If you make it 3%, it will work because it's calculating this one for any value of alpha. No need to be 5% or 10% or 1%. 3%, he can do it for you. 2%, he can do it for you. Okay, now I'll go for 5% also. And go for output range. I would like to have the result just down my question. Yeah. Okay. I press OK. Did you get this result? If not, please let me know. Again, yes, in this case, I have 3 B values. I have 3 B values. Okay. Last time I have 2 B values because I have 2 null hypotheses, one for the rows and one for the columns, which is fair enough. One for the first category, categorical variable, and the second one for the column categorical variables, right? What about this one? Why I have 3? I said, yes, because I mentioned before you have with replicant, so there is intersection between the rows and columns must be considered in this case, right? Okay. Also, you compare each B value from these 3 by your value, your alpha value you input to when you are doing this test, right? Okay. Let's go for the how to write the result up to, as I said, you have 3 null hypotheses, one for rows, one for columns, right? And one for the intersection between them, right? And you have the opposite of all of the 3, which you call it the null hypothesis, right? So you have a null hypothesis for the row, okay? For the column, sorry, with the core groups, and you have null hypothesis for the rows, which is a blends or fertilizer, and you have the third one is the intersection between groups and blend, right? So this is the 3 you are going to reject or accept up to the B value. Let's go and take them, okay, to my Excel. Let's see which one I'm going, sorry. I have to make it very small. Okay, sorry. Okay. Now you have it here in the Excel. He given you for the column, for the sample, or for the rows, and for the columns and for the intersection, right? So you can answer the question up to the comparison between the B value and the alpha, right? Okay. So yes, the B value here is bigger than the alpha I insert when I'm doing this test. So I'll accept the null hypothesis. Okay. So there is no significant difference between the effectiveness of the fertilizer for the different groups. For the other B value, I have it less than 5%. So this is for what? For blends or columns, rows, sorry. So I'm going to reject the null hypothesis for this blends. So there is a significant difference. Okay. as
Doctor, I got different numbers than yours.
no, this one is not mine. It's done maybe for different alpha. Okay. So if I catch in the Excel now, here you have different.
Yes, I have different than you though.
Completely different, affect the result.
The total is 39,640.
Which one you are talking about?
The
This
total.
one?
Yeah. Even the p-values are different.
The degree of freedom 2, 3, 6, and 48?
Yes.
Okay.
But
So, no, the total of degree variable, forget about it. I'm talking about the b value.
Yeah, they are different.
Completely different.
Yeah, the last one is 0.0. The last one is
0.5% or less than 5%.
No, they are less than 5%.
It is 0.0.
I got more than 5%. I got 0.622.
And this is also bigger than 5%. This is bigger than 5%. And this is bigger than 5%. And this is the only one less than 5%. Do you have the same? Compare your value here.
Okay.
No, doctor, mine is less than 5%.
Yeah, all of them. 3 of them are less than 5%.
All of them?
Yeah. It might be one of the columns numbers are wrong.
Yeah. This is so I have to check mine. Can you share your screen, please? I'll get mine out. Share your screen, please. Yeah, okay. Yes, maybe by mistake I input, my input is not correct, right? So okay, the first one you are going to write what?
Less than 5%.
Less than 5%. Less than 5%. All of them are less than 5%? No, this is bigger. How it comes 0.06 less than 5%? It's bigger than 5%. And this one, yes, this is a less than 5%. Let's go for the columns. The column represents what? Represent the groups, right? So I will send you the null hypothesis, okay, and check. So if it is less than 5%, what you are going to say? If it is less than 5%, we reject the null hypothesis, right? So what you are going to write? There are significant difference between the effectiveness of the fertilizer, right? For the different groups, right? I'll give it to you.
Doctor, but in the columns it's more than 5%. It's not less than in the columns.
No, I'm talking about the blends in the rows, right?
Yeah, okay.
Okay. So this is the sentence you are going to write in front of the blends. Okay. I gave it to you in the chat. Okay. Because it is less than 5%. What about the second one? The second one is bigger, right? What is your screen?
Yeah, just a second.
Okay. Yeah, the second one. cannot see this. Yeah, the second one is the columns. The columns is what? It's the groups. Fine?
Yes, greater than.
So I'm going to say, because it is bigger than 5%, as I see from your screen, it is bigger than 5%. So what you are going to say, you reject, or you cannot reject the null hypothesis, right?
Yeah, we accept them.
Yes. So what is the p-value? Just to write it down for you here. 0.06.
You actually gave me. You gave me the p-value is 0.0649 for the groups. That's the columns.
Yeah, this is.
So this is.
Yeah, this is the second one. Sorry, this is the second one. But for the first one.
Okay, so the first one is 0.0.
Can you change this less than by bigger than? 0.649 is bigger, not less. Yes. Thank you. Okay.
Okay, so
for
we
the
accept
second one.
Here,
for
right?
the second one, okay. What is the p-value? It is less than, or I will send you also the sentence for this one in the chat, just to put it in your, okay. This is for the groups. I give it to you.
So this is for the sample?
Yes, samples or groups. Okay. Excellent. So can you correct the?
Okay, but doctor, for the column.
Can you correct the values if it is
we
wrong?
Accept.
Yeah, it is less than b. Yes, okay. For the intersection. For the intersection. I'll send you the. Sorry.
I have a question. How do we reject both null hypotheses if one of them is greater than and one is less than? I think for the groups we
have three null hypotheses. We have three null hypotheses. Remember, we don't have only one. We have three null hypotheses. This is what I start with. This is peculiar one. This test has no one null hypothesis and one alternate hypothesis. There are two without replicant, and there are three null hypotheses with replicant, right?
Yes.
So yes, it's not normal to accept and reject at the same time if it is one, but there is not one null hypothesis. There are three null hypotheses, right? Easy. This is the last sheet in our assignment. If you have any inquiry, any question in the previous test or any assessment, let me know. And I'll stop recording now.
Doctor, can you put the summary on the chat?
Summary